All right, guys. Here's what we got going on. Uh, okay, so we have this square right here, and I'll on the next SI. If you see this before, then if you don't see it till then, whatever. It's all the same. I'll be giving one of these squares to everybody. It'll be a part of the worksheet. What we're talking about here, though, is the concentration of hydronium and the concentration of hydroxide when we talk about these two things. Right, so let's choose something appealing to the eyes. Let's go with this color right here. Something different. So this part right here is derived from knowing that the concentration of hydronium, or H+, those are interchangeable. Remember, H+ is the same thing as H3O+, times the concentration of hydroxide is equal to 1.0 times 10 to the negative 14. If you remember this equation, you can derive both of these. Because if you want to know what the concentration of hydronium is, you take 1.0 times 10 to the negative 14 divided by hydroxide, the concentration of hydroxide. You should also know, just in case, that 1.0 times 10 to the negative 14 is equal to kW. Um, these right here are your Ka, right? Um, your H plus, and then this is Kb. But that's not something that you guys will really have to worry about too much. What you really need to know is the concentration of hydronium times the concentration of hydroxide equals 1.0 times 10 to the negative 14. From this to in a neutral solution, you should also know that the concentration of hydroxide equals 1.0 times 10 to the negative 7, which is going to equal the concentration of hydroxide. Hydronium equals hydroxide in a neutral solution, right? Because you don't have more than one or more than the other, or more of one than the other, is what I'm trying to say. So this is neutral. Neutral. Okay, so that explains this top part right here. Now, the pH scale is something we should all be, relatively familiar with. 1 to 14, right? 7 being neutral, 14 being extremely basic, like melt your hands and face kind of thing. Same thing with 1 being extremely acidic. It's technically 0 to 14, but usually see stuff lie within 1 to 14. Um, melt your face off acid, melt your face off base. Neither one of those you really want to mess around with. So, if we want to go from our pH to our pOH, these both are derived from the fact that 14.00 is equal to the pH plus the pOH, right? So if we want to find the pH, we take 14, right? pH equals 14 minus the pOH. pOH equals 14 minus the pH. This one should be fairly simple. So if you have to go from your concentration of pH, or if you have to go from your pH to your pOH, it's simple math. A lot of cases they'll have you going from like your concentration of hydronium to pH or concentration of hydronium to pOH, in which case it'll be multiple steps. So that being said, if you memorize this equation right here, which this one should be the easiest to memorize, and this equation up here, should probably watch where my hand is going as opposed to what's going on the screen. You memorize those, that takes care of going back and forth between these, right? Between those and between those. So these are the ones that are a little bit tricky, especially if you've only had like Math 70 or Math 90. These ones are, a little out there. It's just something you're going to have to memorize. But to get the concentration of, or whoops, it's still going on. No, why are you not erasing? Whatever, dude. The keys are backwards. So if you want to know the concentration of either one, let's go with the concentration of hydronium here. The concentration of hydronium is going to be 10 to the negative, it's going to be pH. If you want to know the concentration of hydroxide, that is going to be 10 to the negative pOH, right? Now, if we want to go backwards from this, say we're given the pH, like in this problem down here, we're given the pH. We want to find the pOH and the H+. I'll do the work underneath this one, but if you're given the pH, you'll use this formula to get to your H+, right? But if you're given the concentration of hydronium, sorry, is what I meant to say, your pH will be equal to the negative log of your H+. And then the same goes for the pOH. pOH is equal to the negative log of hydroxide. Right, so that's these formulas right here. So if you know these, technically you really only have to memorize one of them. If you memorize the hydrogen one, or the hydronium one, you know the concentration of hydronium is 10 to the negative pH, or the pH is equal to the negative log of hydronium. It's the same thing for the other one, but instead of using pH, you're going to use pOH, and instead of using H+, you're going to use OH-. Okay, so let's go ahead and work out a problem. Okay, so a solution is found to have a pH of 9.250. What is the pOH, concentration of OH-, and concentration of H+? So the easiest one to do, we know our pH equals 9.250. So our concentration is going to have 3 sig figs, right? It's what comes after the decimal, okay? But let's do our pOH first, because that's going to be the easiest one to do, right? pOH equals 14 minus my pH, which equals 14 minus, or it's going to be 14.00, whatever you have sig fig wise. So in this case, 0.000 minus 9.250. My pH is going to equal, because my brains are so good. No, I'm just kidding. I worked it out on the board that you guys can't see. My pOH is going to equal 4.750. Right? And then, so now I have my pH and I have my pOH. Now I can find the concentration of hydronium and concentration of hydroxide. And this is the way I like to go typically. I like to have my pH and my pOH, because I find it a little bit easier to go 10 to the negative pH or 10 to the negative pOH. Basically you could go from pH to concentration of H+ to concentration of OH- to pOH if you wanted to. I prefer this way. I think it's a little easier. Personal preference though. That's what's cool about that square. You can go really any way you want with it. So concentration of H+ equals 10 to the negative pH. So it equals 10 to the negative 9.250. And then, so we know for our sig figs, we're going to have 3 sig figs in our answer, because we have 3 places past the decimal. So when you do the math, you get 1.77, right? Times 1.778 actually, times 10 to the negative 5. Check my algebra on that just to be safe. So when you round off, you should get 1.78 times 10 to the negative 5. That'll be my concentration of hydronium. Concentration of hydroxide is going to be worked out the same way. 10 to the negative pOH, which we solved up here, which equals 10 to the negative 4.750, which is going to equal 5.62 times 10 to the negative 10. I didn't write the first insignificant number because of the fact that I knew I wasn't going to have to round off. So that would be your answers. That would be all. All right, so let's move on to the next problem. Okay, a solution has, let's use a different color. Let's mix it up here. Okay, a solution has 2.88 times 10 to the negative 3 moles per liter of hydronium ion. Sorry, I forgot to put that in. Once you hit enter on this, like, it's stuck there. What is the concentration of hydroxide, pH, and pOH? Pretty much the same question as last time, but instead, I mean, obviously it's different numbers, but instead we're given the concentration of hydroxide instead of the pH. So, since, or of hydronium, not hydroxide, sorry. So H plus equals 2.88 times 10 to the negative 3 moles per liter is molarity, right? So that's my concentration. Oh, sorry. Totally, yep. That's supposed to be there. And that's supposed to be there. It's okay though. Most of the stuff's multiple choice. So anyways, so we know that this is my concentration of H plus. We want my concentration of OH minus. That's going to be equal to, go back to the water equation, right? 1.0 times 10 to the negative 14 molar. Actually, you don't need the units on this because you're going to know it's going to be molarity divided by 2.88 times 10 to the negative 3. And that is going to give us 3.472 times 10 to the negative 12. And then 3.47 times 10 to the negative 12. That would be our answer, and it's molarity, right? Okay, so we have both concentrations of hydroxide as well as hydronium, right? Hydronium. So now we can figure out what our pH and pOH is, right? So our pH is going to equal the negative log of H plus, which equals the negative log of 2.88 times 10 to the negative 3. Don't worry about putting units on, especially pH doesn't have units, so don't worry about that. And you know your concentrations are going to be in molarity. So as long as you remember that stuff, you should be fine. Because if you put an M right here for molarity, the two M's are going to cancel out. It's not going to work. Just make sure you have your unit at the end. Okay, so when you do this, when you put this in your calculator, double check my algebra. Not perfect. You get 2.5406. But we know this right here has 3 sig figs, so we're going to want 3 decimal places after, right? So 2.541 is going to be our pH. Now from here, we can go one or two ways. I wanted to kind of show you guys the log version, so I'm going to use the log version. But once you have this, if you hold all of these sig figs that you have in your calculator, you can go 14 minus the answer, which will be all these sig figs, and that should give you your pOH. But let's do it the other way. pOH equals negative log of OH minus, which equals negative log of 3.472 times 10 to the negative 12, which equals 11.4593. Remember, 3 places after the decimal. That will give us 11.459. You should get about the same answer if you do it the other way. If you guys are having trouble putting it in your calculator, just please let me know. I'll do what I can to help you. I don't know every single calculator because I'm not a manufacturer or anything, but I'll do what I can to help you guys. If you guys, we'll be working on this more on SI. Email me if you have questions. Yeah, I hope this helps a lot, guys. Best of luck. Goodbyes.